To go along with problems about conditionals, I would say that problems involving lists, iteration, and loops are pretty much the bread and butter of the AP CSP exam. You'll see a lot of these problems in the exam. We're going to actually bunch up iteration, loops, and lists together in one section because they go really well together and a lot of the questions actually involve both. So let's get started with this. This is a pretty easy question, I would say, on the topic. And what we see here is we have a code segment that contains a list that we see up here at the top. And we notice that this list has 6 items. It's got 100, 20, 300, 40, 500, and 60. Right, so these are the 6 items right here. Now what this problem is going to do is it's going to iterate through this list by using a loop. And in this example, it's going to use this for each loop. So these for each loops are actually going to be quite common in this exam. There's a couple different types of loops that are introduced, and they might be different from the language that you might have learned. If you use code.org, for example, there's no such thing as a for each loop in JavaScript, but this will use them. But generally, they'll be pretty straightforward to understand what these loops do. This one, for example, will go through each item in the list. So it'll start from the left, and it'll go through each item. And each item will have its value under item. So item will be 100, 20, 300, 40, etc. This loop in particular, what it's going to do, it's going to go through each item, and if the item's value is greater than 90, it's going to display it. So for this list, clearly what it's going to do is it's going to display 100, 300, and 500 in that order. Therefore, the answer is C. Notice that D is incorrect because D puts the items in the wrong order, right? So it's going to go from left to right, not from right to left. Here's another fairly common problem type. This one is going to give you a list, and we're going to also iterate through it, in this case also using a for each loop. But what it's going to do is it's going to count how many times something happens, right? In this case, it's actually not even just counting how many times something happens. This problem is actually pretty interesting in how it's doing the count, because we're not just counting with a straightforward count. And so what's going to happen is for each of these items, it's going to calculate this, item mod 2. Now, what you might recognize about item mod 2 is that it's going to take the modulo of the item. If you remember, the modulo is like a remainder. So basically what it'll do is, if the value is even, such as 4 or 2, item mod 2 is going to be 0. But if the number is odd, like for example this one here, or this one here, item mod 2 is going to be 1. So what this will do is, whenever we run into an odd item in the list, it'll add 1 to the result. Otherwise, it'll add 0 to the result, right? So if we go through this list, we'll see this here will be 0, 0, 1, 0, 0, 1, and 1. So we're actually going to add 0 for each of these and 1 for each of these odd numbers. Basically what this is doing is just counting how many odd numbers are in this list. So if we go through the list one by one, we'll have 4 is going to give us 0, etc. And basically it'll add 1 for 5, 3, and 1. So result will be 1, and then 2, and then 3. Therefore, what this is going to do is it's going to do all of that, and then it's going to display the result at the end, and that's going to be a value of 3, which is the last value that we set result to. Here's another somewhat similar problem. This one has 2 counters though, and what I recommend to do when you have something like this is just keep track of the counts, right? So I'm going to keep track of the counts over here next to count 1 and count 2. Well, let's look at what the problem is doing. We have a list that has 5 numbers. We have -2, -1, 0, 1, and 2. And we're going to use this for each loop right here. And what it's going to do is it's going to check if the value in the list is greater than 0. So if it's greater than 0, so basically for these 2 values, 1 and 2, it's going to add 1 to count 1. And for everything else, it's going to add 1 to count 2. So basically what this will have is it's going to count these numbers that are greater than 0 as count 1, and these numbers as count 2. So when it runs into these, it'll add -2, -1, and 0 as 1, right, because it's adding 1 to these each time. And it'll put that on count 2, right, because it's in the else. These are not values that are greater than 0. So for count 2, we will have 1, and then 2, and then 3. And then we get 1 and 2 here, and those will go into this branch right here, right, because they're greater than 0. So we'll add 1 and 2 to count 1. So count 1 will have a value of 2, and count 2 will have a value of 3. Now notice that we kind of went through that the long way. We basically went through and calculated all of the values. I would say that you don't really have to do it like that. You could just look at this and reason through it and say, well, what is this really doing? It's saying if the value is greater than 0, we add to count 1. Otherwise, we add to count 2. And we could just look at the list and say, well, we don't have to go line by line here. Clearly, there are 2 values that are greater than 0, and there's 3 values that are not greater than 0. So clearly count 1 will have 2, count 2 will have 3 values. So that's another way to think through this. All right, now here's a problem about indices, and here's actually where we have to make a pretty important point about the AP exam. There's a lot of different curricula for AP CSP. So for example, some people may take BJC, some people may take code.org, which I believe is the most popular, and code.org uses JavaScript. And JavaScript is what's called zero indexed, which means when you have a list, the first index in a list has an index of 0. However, for the AP exam, we do not use that formulation. Instead, in AP CSP's exam, you can read in the actual documentation that the first index is 1. So actually, in AP CSP, we have 1 indexed arrays. Right? So the indices for this array would be index 1, 2, 3, 4, 5, and 6. Right? So whereas in JavaScript, this would be index 0, here it's going to be index 1. Do keep that in mind. It's actually going to be pretty important to recognize that in the exam. Now, with that out of the way, let's look at this problem. Here we have a list right here called the list, and it says here that we can assume index 1 is a number between 1 and length the list, right? So if you took code.org, you might remember that you use length of the list minus 1 as the last element in the array. That's because it's 0 indexed. Don't forget that now we are indexing starting with 1, which means that length the list is actually the last item. It would be this one right here. Whereas 1 would be this item right here. Which means index 1 is any of the items in the list. It's an index between the first and the last items in this list. Next, it says index 2 is a number between 2 and length of the list minus 1. And notice, by the way, both of these are inclusive, which means it includes those numbers. So what this means is that index 2 is going to be indices 2 all the way through 5, because this list has 6 items, right? 1, 2, 3, 4, 5, 6. And this is going to be between index 2, 3, 4, or 5. So it's any of the items over here. So index 2 is going to be one of these items, right? It's going to be the index for one of these 4 items. So the question here is we have x is list index 1 plus list index 2. And we know that index 1 can be any of 1 through 6, and index 2 can be any of 2 through 5. So basically what this is doing is it's adding any number in the list plus any of these 4 numbers. And it doesn't tell you which one. And what it wants to know is what is the largest possible value that the variable x can have after the code segment executes. Which means we want to pick what is the biggest value where we can add any of the items in the list to any of these 4 items over here, right? Index 1 through 5. So basically this is what is the biggest item in the list plus the biggest in this small subset right here. So the biggest item in the list is clearly 9. And in this set, the biggest item is this one right here, 5. So the largest possible value is going to be 9 plus 5, which is 14. So therefore the answer is B. Here's a particularly tricky problem involving indices and iteration. So in this one, we have a list called even list. And what we want to do is we want to populate this with even numbers starting with 2. Very important that we want to begin with 2. And we want to make sure that they're all even, right? So this is going to store 10 consecutive even integers. So if we want to begin with 2, it's going to be basically 2, 4, 6, 8, 10, 12. There's going to be 10 of these, so it's going to go all the way up to 20, right? Now most of this is actually just details. Let's just worry about these first few right here. So just 2, 4, and 6, for example, right? We'll see why it doesn't really matter what others we pick. What we want to be able to do here is, given that we start with 1, I is an index that starts at 1, we want to figure out what the missing code is here. And we have this repeat, which just repeats 10 times, right? Now let's see if this first one here does what we want. A is automatically wrong because the very first thing that it's going to do is it's going to add I to the array, just directly. And you can see here that I is 1. So the first item that will be added to the array is 1. And that's not correct, right? We don't want an array or list with 1. And you'll even see that it goes on to add 3 and then 5, etc. So this is very much incorrect. This is not correct. But you don't even have to look at 3 and 5. You can automatically see right from the get-go that it's going to do the wrong thing. Now let's look at B. B is going to, right from the get-go, it's going to make I go from 1 to 3. So it's going to add 2 to it. So the first value that we add to the list is 3. So this is even more incorrect, right? So here we add 3, and then eventually we'll add 5, etc. But right at the beginning, we already added the wrong number to the list. So it is also not B. Now let's look at C. C, the very first number that it adds is 2 times I. And I starts at 1. So the first number we add is 2, right? So we're going to add 2. And then we're going to add 1 to I. Now at this, you might kind of squint your eyes and think, oh, is the number going to be 3 next? But it's not, right? Because I is going to be 1 more. So here we'll see that I starts at 1, and then it'll be 2, and it'll be 3, 4, all the way up to 10. But the numbers that we add to the list are 2 times I. So the numbers we add to the list are going to be 2, and then 4, and then 6, and then 8, all the way up to 20, right? So we can see here this will add 2, 4, 6, 8, etc. Which is what we want. This is the correct answer. So C is the correct answer. Now just to complete this, let's look at D and see why that's not the right answer. Even though it looks like it's doing pretty much the same thing, because the order of the iteration is off, you'll notice the first thing it's actually going to do is make it so I goes from 1 to 2. So the first value of I is going to be 2. And the first thing we add to the list is 2 times I. At this point, because we're doing this in order, 2 times I is going to be 4, which means that the first item that we add to the list here is going to be 4 instead of 2. So we're going to add 4 and then 6 and then all the way to 20. Actually 22 in this case because we skipped the first one. And that's not correct. That's not what we want. So very important to note that the order in which you increment the index is critical. Let's go over one of these more unique problems where we're actually given a new function where it does something usually associated with a list. So these are actually pretty common for problems about libraries. In this case, we're given a problem where we have this new function called isFound. This function takes 2 parameters, takes a list and an item. And what this says is that isFound is going to return true if the item appears in list and false otherwise. So basically we can use this to see whether or not item is in the list. Now let's look at what this code is doing here. This code is going through all of input list 1, and for each of those items, it's checking whether or not that item is found in input list 2. So basically it's checking whether or not each item in input list 1 is also in input list 2. Now notice there's also a third list here called result list, and it says that it's initially empty. So what this is doing is it's going through each item in input list 1, checking if it's in input list 2, and if it is, and only if it is, then it's going to append it into result list. So the question here is, what are the contents of result list, assuming it started out empty? This is actually pretty straightforward, right? We go through every item in list 1, and if it is in list 2, we add it to results. So clearly what this is it's showing only items that are in both lists, which is B right here. Only items that appear in both input list 1 and input list 2. So this is a good problem where you want to solve it by reasoning through it. You want to look at the problem carefully, try to figure out what the code is doing, and use critical thinking to see what this is actually accomplishing. This is not a very good problem to just solve by iterating through it and solving it out. It's a good one to look at it at a high level and try to understand what it's doing instead. All right, let's go through the last 2 problems, which are fairly tricky problems compared to the ones we've seen so far. So in this one here, we are implementing a procedure called isIncreasing, right? And it actually defines here for you the concept of what it means for a list to be increasing. Here it says a list of numbers is considered increasing if each value after the first is greater than or equal to the preceding value. In other words, it just means that the numbers in the list are in increasing order, right? So for example, 1, 2, 3, 20, 40. This is clearly a list in increasing order, but this list is not. 1, 3, 2, right? Because here we see that this value is greater than this value, which means that it's not in increasing order. In this case, this problem gives us just one list, right? Number list. And we're passing it in as a parameter, and it's going to give us a result of false if it's not in increasing order, and true if it is in increasing order. So what it checks here is it's telling us that this doesn't work, that this function that it gives us here doesn't work, and it's asking how do we fix it. So this is another type of problem where critical thinking is probably the best way to see through it rather than trial and error or things like that. So let's look carefully at what we're doing. So the first thing to note here is that the count starts at 2 instead of 1. So that's the first thing we should think about. And then it's going to repeat until count is greater than the length of the list. So basically it's going to go through the whole list. Now here's the big thing to look at. It says here if number list count is less than number list count minus 1, it's going to do something, right? It's going to return. But let's try to figure out what this means. So number list of count is going to be, let's say we have a list. It's going to be whatever we're at right now, right? So we start counting at 2, right? So let's say we have 2, 3, 4, 5. If we start counting at 2, count is going to be index 2. Remember, we start counting at index 1, so this will be index 2 right here. And number list count minus 1 is going to be one index before it, right? Because count minus 1. So that'll be this number right here. So what it's saying here is if the value in index count is less than the previous value, so this one here, it's going to return true or false here, right? In this case, it'll return true. So let's see what that means. That means that for this list right here, it's going to compare each two values. So a value and the one right before it, and then this value compared to the one before it, and then this value compared to the one before it, and then this value and the one before it. And it's going to return true if we ever get to the situation where this value right here is smaller than the one before it, right? So we remember that example. We had like, say 1, 2, and let's say then we have 5 and then 4, right? If we get to this situation here where we look at 4 and then we compare it to the one before it, 5, here we see that this one, 4, is smaller than 5. Now in this case, this code would actually return true here. And returning true here means that it's saying that it is increasing. But we see that that's clearly a contradiction, right? That's not true. In this case here, 1, 2, 5, 4, this would be returning true here when we get to 4, even though it should actually be returning false, because this is clearly not increasing. On the other hand, look at our previous example. This one here is increasing, right? But if we look at what this code would be doing, we're going to be comparing every two values, and we're going to get all the way to the end without ever returning here, because that means we made it through every value and at no point was the current value smaller than the previous value, right? We made it all the way to the end without reaching that condition. Then we would finally get to line 12 right here, which would tell us that it's going to return false. So in this case, when we should be returning true, because this is an increasing list, we're instead returning false. So what is the conclusion here? It means that these two are actually reversed, right? We should be returning false because it's not increasing the moment we see that a value is smaller than the previous value, and we should be returning true if we made it all the way to the end without stopping to say that it's not increasing. In other words, the answer is C. Lines 8 and 12 should be interchanged. This is line 12 and this is line 8. So another way to really see this problem is you look at it and you see, does this condition right here, this condition clearly shows us it's comparing a number to the one before it. And if that is true, we detect a case that breaks the condition that it's increasing. Do we want to say that it is increasing or do we want to say that it's not increasing? We can only really tell that it's increasing after we've checked every single value. But the moment you spot a contradiction, that's when you want to stop and say, hold on, this thing is not increasing. That would be this right here. That's when we want to return that it's not increasing. I would consider this to be a fairly tricky problem, by the way. All right, let's end with one last problem that's a little similar in a way. Here we have a list, and in this one actually we start counting. We have an index j, but what you see about j here is actually, whereas normally we start with an index of 1 or 2 or whatever, in this one we actually are going to start from the end. It's going to start with j equals length of my list. So we're actually going to be counting from the back of the list. We'll see why in a little bit. So what we're going to do is we're going to loop through the whole list until j equals 1. So in other words, we start from the back of a list. So for example, we start from here, and we move backwards until we get to the front of the list, until we get to index 1. And that's when we stop, right? We're going to repeat until j equals 1. And by the way, you can see that we're going backwards because instead of going j equals j plus 1, we're actually doing j equals j minus 1, right? So we're going backwards. We're walking through the list back. So that's all good. We're traversing the list backwards. But what is this actually doing? So what it's doing here is it's saying if my list of j equals my list of j minus 1, we're going to remove something from my list, right? We're going to remove that index. Now this part should look pretty familiar from the last problem. Here we have j minus 1 and here we have j, right? So if this is j, this is going to be j minus 1, right? So just like in the previous problem, we're going through this in pairs. We're going to go an item and the item before it. When j is this, j minus 1 is this. And when j is this, j minus 1 is this, right? So we're going to compare items kind of in pairs. We're going to look at an item and the one right before it. And we're going to do that all the way until we get to this point right here. Once j is the first item, we stop, right? We're going to repeat until j is the first item. So when we get to this point, we stop. Now what is it doing? It's actually comparing whether or not j and j minus 1 are the same. And if they are, it's going to remove them from the list. So here's another one where, once again, it's good to reason through the problem. Clearly what it's doing is it's checking if any two adjacent items are the same. And if they are, it's going to remove them from the list. So if these two items are the same, it's going to remove item j. So in this case, it's going to remove j. Right? And same here, it's going to remove this item right here and this item. So these are the same, so it's going to remove this one. And these two are the same, so it's going to remove this one, right? So for this one here, we end up basically removing 10, 20, and 10. Now notice here that the intention for this function is actually to remove all duplicate elements from the list. And here we see that although we remove a bunch of duplicates, what we end up having is a list that looks like this. It has 10, it has 20, and it has 10. Although we tried to remove duplicates, and we did remove some duplicates, we still did end up with two duplicates here, 10 and 10. It seems pretty clear, by the way, if you look at this problem, that the time where it's going to fail is if you have duplicates that are non-consecutive. So in this case, for example, you have 10 here, and then you have something between that and the other 10s over here. So you have kind of 10s that are separated by other numbers. So those kinds of duplicates will fail to be removed. So we see from that A is clearly one of the two answers. Notice, by the way, there's two answers. Make sure to pay attention to that. We notice that this one should actually work fine, right? It's going to remove 20. It's going to not touch 10. It's going to remove 30, and it's going to remove 30 here. So here we end up with 30, 10, and 20. So this one is just fine. This does not contradict the results. Notice here it's looking for something that does not work as intended. And here we have 40, 20, 10, 40, 50, 30. This is pretty clearly going to remove none of these numbers. None of these are consecutive duplicates. So since none of these numbers are getting removed, we clearly have a 40 and a 40 here. So that's not going to work as intended. So this one's going to fail. So these are the two answers. You notice this one here, by the way, it's going to remove all of these 50s. It's going to end up with just 50. So this one still works correctly. Now I want to leave with one last note here. Why did we actually start from the back here? It's actually kind of interesting. But if you have a list and you remove an item from the list, it's best to start from the back if that's what you're trying to do. And here's the reason why. Let's say you start from the front, right? And you have like this, 10, 10, I don't know, 20, 20, 30. And let's say that the first thing you do is you compare these two numbers and you remove this first number. This actually, by removing this, you will actually shift the whole list over. It'll become this. However, your index here would still be, your first index will be 1, and then 2, and then 3, and then 4. But since you began by using indices 1 and 2, since the whole list shifted over, as soon as you go to the next index, you will have actually skipped a number because this number right here, which used to be over here, has actually shifted to the left. So if you are removing items from a list, you want to make sure that you account for the items shifting over, either by changing the index, by removing 1 from it, or by starting counting from the back. It's a little bit of a tricky concept, but it's kind of worth thinking about it a little bit.